All right, so for this one, this is an opportunity for you to demonstrate your MAD experiment writing skills. We want to long wooden plank and cut the plank into pieces that have different lengths but the same width and height. The students also have access to other equipment commonly available in school. How could they determine the force of kinetic friction exerted on one of the wooden pieces? All right, so what needs to be measured? Well, the frictional force, the length of the block, the width of the block, the height of the block. Here's what it might look like. So there's more than one answer here. Here's a table. Here's a block. Here's a ruler. Here's a scale. I'm going to pull the block. Pull each procedure could be pull the block, a piece of wood across the table with the scale at constant speed and measure the frictional force on the spring scale and measure the dimensions of the block and calculate the area and volume of each block. And here's some data. They want us to graph it. On the grid, plot a graph of the data that could be used to test Dominique's specific hypothesis, which was, I didn't even read it. The force of kinetic friction on an object is directly proportional to the area of the object. Okay, all right. So we could graph force and area. And this could be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. This would be 2.5, 5. Oops, I'm off camera. Sorry. 7.5, 10, 12.5. And this is the area in square meters times 10 to the negative third. And this is the force in newtons. And so as we get the data from the data table, it starts graphing out like this, about here, maybe about here, about here, about here. It looks pretty linear. So then we draw a line that goes to the origin. And does it support the hypothesis? Yes. The graph shows the force is directly proportional to the area. There was a flaw in the procedure that renders the conclusion invalid. Briefly explain what this flaw was. Each piece of wood has a different volume, so they all have different masses. The friction force depends on the normal force, which depends on the mass. Since they didn't hold the mass constant, the conclusions are invalid. Right? Mass not constant. Therefore, normal force not constant. Because friction is equal to mu times the normal force. So they were holding this constant and looking at this, but this was changing, right? So there you go.